28, and the characteristics of the average compound. So the first thing, a compound is a substance like an element, but what makes a compound different is that a compound is made up of different types of atoms. So a compound has to have at least two different types of elements present in its structure. And these different types of atoms combined, or they bond in a fixed ratio. And we understand that if it's fixed, it means it does not change. So here is a huge idea, that if we change that ratio, then we actually change the type of compound. So that new or different ratio, so if we change that ratio, that new ratio has a different chemical name. I'm just going to put chem for chemical, a different chemical name. It has a different chemical formula because the ratio is different. And as a result, it has a difference in the physical and chemical properties. So take a look. We have talked about this. So we have water, whose chemical formula is H2O, versus hydrogen peroxide, whose chemical formula is H2O2. Water, the ratio of hydrogen to oxygen is a 2-to-1, versus the hydrogen peroxide, it's a 2-to-2 ratio. Take a look at the structure. So water, the center of it is an oxygen which is bonded to two different hydrogens, and it creates this bent structure. But in hydrogen peroxide, the two oxygens link together, and then each individual oxygen bonds to a hydrogen, and they create a slight bend. So when you take a look at the structures, that one extra oxygen really changes how the molecule looks. Now, just as an example, water, that 2-to-1 ratio of hydrogen oxygen, our life relies on it. We need it to remain hydrated in our cells. And another use of water is that it can be used to put out fires. We use it to wash our skin or hair, right? We need it to stay hydrated. Those are some common uses for water. Now, you take this slightly new ratio, 2 hydrogens to 2 oxygens. We have a different structure. You don't want to wash your skin with hydrogen peroxide. So hydrogen peroxide, if you get it on your skin, it's going to irritate your skin at a minimum. So it's going to irritate your skin. And depending on the concentration of it, how long you leave it on, it could create a burning sensation. And it can actually bleach the color of your skin or hair. So bleach the color of your hair. I mean, hey, some toothpaste use hydrogen peroxide in there to whiten your teeth. So it's bleaching out the stains. Water doesn't do that. Okay, so moving on, another characteristic of compounds. So a compound's properties are different than the properties of the individual elements in the compound. So take a look. We have an element, Na. We have another element, Cl. And when they combine, they form this compound, NaCl, which is our most common salt. So Na, if you find it on the periodic table, is to the left of the stair step. So that means it is a solid. Cl is to the right of the stair step. It is a nonmetal, and it actually exists in the gas phase. And NaCl, the salt that we put on food, you've seen it in the salt shaker, it exists as a solid. Now, Na, being a metal, it has a pretty common gray-silver color, so a very light gray-silver color. So it has a silver color. So it's silverish. Chlorine, it actually, even though it's in the gaseous phase, it has a greenish color to it. And NaCl, when I know that when you look at it in the salt shaker, it looks white because that's how light is refracted off of it. But NaCl, if you saw a big enough crystal of it, you would see it actually lacks color. So we would say it's colorless. Now, melting point. This is the temperature in which a substance transitions between the solid and liquid phase. So this is that temperature. So if you take a look in your reference table and you go to your table S and you look up sodium's melting point, it is 371 kelvins. So for mel, it's kind of low temperature. And if you look at chlorine's melting point, it's 172 kelvins. But when these two elements form a compound known as sodium chloride, take a look at this melting point temperature. The melting point temperature of this salt is 1074 kelvins. A huge difference in the melting point value when they combine as a compound versus as individual elements. Now, take a look at this. When you put each of these in water, what happens? When you put NaCl, salt crystals, in water, they dissolve. That means they are soluble. Now, chlorine, it's in the gas phase, and when you try to put it into water, it does not dissolve. Gases tend to be insoluble in water. Now, Na, this metal has a very unique relationship with water. When you put it into water, it actually goes through a chemical reaction and it reacts with water. So I'm going to put RXN, so reaction with water, and it's super cool. The Na, when you put a little pellet of it in water, it zooms around the surface and you hear a sizzling sound. And one of the things produced is hydrogen gas. And typically, if there's enough heat there, it ignites and you will see a yellow flame on the water. So it's pretty cool. It's a very rapid and very exothermic process when sodium touches the water. We'll have to find a YouTube video of it. So here we go, the last part. Now, the other thing that makes compounds unique as a substance compared to elements is that compounds can actually be chemically decomposed. Meaning that we can break down compounds, so we can break them down, and we can change them into different, simpler substances. So here is an example. Hydrogen peroxide. When you allow it to sit in the presence of light, it chemically breaks down. So remember, we have this structure of the hydrogen peroxide. So this is a compound, and what it breaks down into is it will produce water, whose structure is different, has a different ratio, but it also produces and sets free the element oxygen. So now when you look at it, we start off of a structure that has 4 atoms, and it's broken down into 2 simpler ones, one structure that only contains 3, and another structure that contains 2 atoms. So here we have a compound, and each particle, there are 4 atoms per molecule, and it is decomposed into a smaller compound that only contains 3 atoms per molecule, and it also sets free an individual element, and this element, because it's a diatomic, there are 2 atoms present per particle. So compounds can be broken down, bonds can be snipped, and it is changed into 2 smaller substances.